Unit 7, Lesson 2, Estimate derivatives from tables. Review. So remember that derivative is the instantaneous rate of change, or the instantaneous slope. But if we're given a table like this, so here's a table, we can estimate derivatives by using the slope formula. It's not instantaneous, but we can estimate it, give an educated guess. Example 1. The number of pages of a book a student has read, P of t, where P is in pages and T is in days, is given by the following table. So here we have a table. The table tells us that when the T is 2, P of t is 17. So after 2 days, the student has read 17 pages. When T is 6, P of t is 24. When T is 10, P of t is 28. When T is 14, P of t is 34. When T is 18, P of t is 37. If we go to decimals and graph it, I've graphed this table, graphed these 5 points. And what we're really looking for is, we know that the graph is going up, but we don't know how it's growing up. All we know is that these points are true. Something like that. The line might look something like this. When x equals 16, which is down here, x equals 16, let's look up. That's our point right here. Our point is right here. We don't know the instantaneous rate of change because the graph could have been going up like this. It could be going like this, like that. There are many ways it could be going. But we're going to estimate that with a straight line. We're going to say, let's say that it's a straight line. If we have a straight line, we can find the slope of this line. How do we find the slope of this line? Well, the run is 4. We're going from 14 to 18. That's 4. The rise is 3 because we're going from 34 to 37. So the slope will be 3 over 4. That will be the slope at 16. So we know that the slope should be 3 over 4. So b prime of 16 should equal 3 over 4 from the graph. Now let's do this algebraically using the slope formula. To estimate the slope at t equals 16, we'll use t equals 14 and t equals 18 to estimate. Those are the two closest points. T equals 16 is right in the middle. Okay. So we find the slope using these 2 points. So the slope, or the derivative at t equals 16, should be approximately slope formula. y2 minus y1, so 37 minus 34 over x2 minus x1, 18 minus 14. So once again, we get 3 over 4. Okay. Part B, using correct units, interpret the meaning of p prime 16 in the context of the problem. This is from our last lesson. Remember our sentence starter, the rate of change of, so we have p of t, right? So it's the rate of change of p with respect to t. Okay, what is p? P is the number of pages of a book the student has read. So the rate of change of the number of pages of a book a student has read with respect to t. T is the time in days, is 3 over 4. But what is the unit of 3 over 4? Well, the unit is the unit of p over the unit of t, which is pages per day. So that means that around day 16, the student is reading about 3 over 4 pages per day. One more example, example 2. The number of bacteria in a bacteria colony, N of t, is given by the following table, where they will also tell us that where t is in hours, so t is in hours, is given by the following table. Okay. We A says use the data in the table to estimate n prime of 6. T comes in 0, 3, 5, 7, 9. To estimate when t equals 6, I'm going to use the 2 points at t equals 5 and t equals 7. So we know that n prime of 6 is approximately n of 7, which is the y2, minus n of 5, which is the y1, over 7 minus 5. That's the x2 minus x1. Okay, that's going to equal to 412 minus 203 from the table. Divide by 7 minus 5. That's 209 over 2, which is equal to 104.5. 104.5. Okay. Part B, using correct units, interpret the meaning of n prime 6 in the context of the problem. So n prime 6 is going to be the rate of change of n, which is the number of bacteria, with respect to t, which is time in hours. It's going to be at 104.5. It's going to be the number of bacteria, so now 104.5 bacteria per hour. So the bacteria is growing at a rate of about 100 bacteria per hour when t equals 6 hours. Okay, that's it.